as we go. I really don't mind. Shall I just get into it, or?
Yeah, go for it. I think all of people here know you.
Brilliant.
Probably they don't know that you're now a Raymond Cajal Fellow, which is a huge honor, right, in Spain.
Yeah, it's one of the top fellowships.
Yeah, go for it. I think all of people here know you. Oops, I think that's. They don't know that you're now a Raymond Cajal Fellow, which is a huge honor, right, in Spain.
Yeah, it's one of the.
Sorry, this is just. It's supposedly live now, and I think I had to switch that off. Otherwise, it keeps playing some delay. Anyway, carry on, Guillermo.
Thank you. Yeah, I mean, that was I'm not sure if there was a feedback loop, but it's a huge honor. So it is. I'm really pleased. Good. So I guess without further ado, let me get started. I'm mostly here today to talk about a couple of things. First of all, just wanted to talk a little bit about about me, about the background, and a little bit of overview. Sorry, just a second. I'm not sure if. Okay. Yes. Sorry, I just have an issue with the screen. Let me. Okay. Yeah. So just, I mean, you all know me. I'm assistant professor at India Networks, and before that, I had been hovering around London for some time, and basically, what I generally do, for those that may not know me that well, I try to apply in general data-driven approaches to understand and mitigate real-world problems in cybersecurity. And I have been working over the last few years in four main topics: a little bit about privacy, but not that much. Kind of like working quite a lot into cyber threats, malware detection, and kind of like software and system security. I have later transitioned towards the cyber fraud and kind of like identifying mass marketing fraud and using automated mechanisms to identify fraudsters. And over the last few years, I have been working a little bit into cyber safety. And basically, what I wanted to talk today is about a couple of papers that I have published this year. That they both work around the same research question. Basically, have been trying to understand what can you do, how can you understand or identify misuse when this happens in a sink, sort of like in a software running in the cloud, for example, like the case of voice personal assistants, or in particular, what you can get as well in instant messaging platforms. And this kind of like these two case studies, they the voice assistant ones appears had been published in the web conference this year, and the other one I'll briefly walk you through my IMC paper from this year. And yeah, before I jump into those two papers, I wanted to kind of like give an overview into the background and the problem. And basically instant messaging platforms like Slack or Discord have become essential collaborative tools. They offer in general a rich environment allowing for instant communication, file sharing, or video conferencing. And the main issue behind these kind of platforms is that in an effort to boost productivity, they also offer support for third-party applications or add-ons, which in the case, for example, of instant messaging platforms, they are called chatbots. And in the case of voice applications, they are called skills, like in Amazon Alexa, or actions in Google Home. And And what happens is that these add-ons, while they offer extra functionality to enrich the way users interact with the platform, and they allow you to perform certain tasks, or better said, these programs can perform tasks on behalf of the users, but they also obviously offer an attractive target for malicious actors. And this is basically what I'm covering today. And similar to smartphones, these third-party add-ons, the chatbots and the skills, they request permissions to perform sensitive actions. But unlike mobile applications, these apps generally don't run in the device of the user, which makes the analysis a bit challenging. In particular, oftentimes these services run in a server controlled by the developer, not even the service provider. Like in the case of skills, it's not Amazon the one that actually runs the server, but it's kind of like a server controlled by the developer. And in the case of instant messaging platforms, what happens as well is that the Slack or Discord send a feed to the chatbots, and they basically tap into the conversations of the users, and they trigger different actions based on what is happening. And the way we have gone about in the two papers that I'm going to be presenting, the way we have gone about addressing this challenge is sort of like creating new methodologies that would allow you to use interrogative analysis to kind of like understand kind of like probe from outside what is the behavior of a certain third-party application, and try to kind of like model what would be the behavior of this application from outside, which is kind of like already presents a number of challenges. Good. So just that was to give like a little bit of an overview of the problem. And the first case study I wanted to talk about, that paper, which is called Measuring Alexa Skills, Skill Privacy Practices Across 3 years. This paper is a longitudinal measurement that we did in 2019, 2020, and 2021 that stems from a previous tool that we published that is called SkillBet, and I'll walk you a little bit through the methodology. Before we jump into all the details of the paper, just wanted to give a bit of like a really brief overview of what is the personal ecosystem, personal assistant ecosystem, and and basically what are the complexities of this architecture. And one of the main ones is that this ecosystem is in constant evolution, and that has driven us crazy over the last 3 or 4 years. Because sometimes when we thought we understood finally the technology and a given platform, would realize that it had changed, and it will continue to change. And yes, as I said, there are many architectures. Every platform has its own different flavors. Amazon Alexa has its own caveats, and the way they work might be slightly different to Google Home. But there are a set of common features, and in the next diagram, what I basically want to sketch is a little bit how this ecosystem works, how these complexities and how these modules interact with each other, and kind of like put an emphasis a little bit into these common features. And basically, what happens is that generally you have a user that is intending to interact with a remote, like a device that has at home, or that is running on your car or in your phone, like in the case of Siri and so on, by a voice, through voice conversation. And generally the service provider, Amazon in this case, or Google or Siri, they process this audio file. They use natural language processing to understand what you want to do. And they run these through a third-party application that is connected to the SPA provider, and what happens within here is where a lot of differences, when like the big differences between each of the ecosystems lie, because many of these platforms, they use machine learning to kind of like decide for you what would be the best third-party application that will offer you a response for your request. Some others, like in the case of Amazon Alexa, it does that, but over a subset of applications. So you have to enable first what are your preferred voice applications, and then whenever you say, "Hey Alexa, what is on the news?" for example, it will choose based on the skills that you have enabled. But if you haven't got enabled any skills that is related to the topic that you're querying and searching, then there is like some mystery, some magic that happens, and you don't know exactly at the end how your request is being submitted to a third-party application, basically. But anyway, what happens later is that you get a response from a third-party developer, and then Alexa takes care of kind of like understanding the text that is behind this application, turn it into voice, and then send it over to the user. So kind of like the main common features that there is in this ecosystem is the open nature of this channel. As I mentioned before, the different AI components that process all this entire pipeline to offer you a response, going all the way from natural language processing to choosing, which third-party application will give you a response and so on. And the fact that there are third-party developers generally giving you at the end a response.
Guillermo, can I ask a question here?
Yeah.
So if I think back to like all the Facebook applications that used to be there like a decade ago, right? Again, there were third-party developers developing on a platform, and then there were issues, security issues, so they kind of shut it down mostly. So do you think it's somehow similar to that? Or is there an additional aspect here, because that routing of which particular application provider, for example, which news provider to choose, that is happening via ML, which might give more randomness to the whole process?
Well, I think in a way there was an opportunity for the industry to kind of like create new technology, and I think in the future this technology is maturing, and I think it will be pervasive in many of our daily lives. But I see some similarities to the problem you were describing, because recently I got to know that Google is basically closing their marketplace for third-party developers to tap into their Google Home assistants. They are called Actions in Google, and it appears that Actions is going to close. They are not going to like completely dump the entire business model. I think they're going to try to rethink it and find alternative ways in which they can secure the users. So if your question was along the lines of this, I think there are similarities. I didn't quite understand what you meant with the AI.
So I thought you said there's some magic which happens that if you don't have a particular news provider enabled or any news provider enabled, then it chooses one at random or something. So it might be that I don't ever want to hear news from Daily Mail, but it sends me there anyway because I don't have a news provider enabled, for example. I don't know what happens or how it chooses. But whereas in Facebook, I either installed an application or didn't install an application. And when I was accessing these third-party applications, which would be mostly like games or whatever, I knew that I was accessing an application. I knew which application I was accessing. Whereas here, it's almost like I don't care which application. It's just give me a weather app that's going to tell me whether I may prefer Weather Underground over AccuWeather, for example, in which case I install that as a skill or an action.
Exactly, which brings, as you can imagine, important issues in terms of security and privacy. Not only because, well, in some platforms you can more or less direct the smart personal assistant to offer you a response within that subset, but even though you may have a subset of skills enabled, you don't have a user interface that would tell you precisely which one is giving you the answer. And sometimes it gets feeds from all of them, but then you don't know exactly which one. So in particular, I think at the moment, if you have two news skills are enabled in Amazon Alexa, it will basically offer you feeds from both of them. But it's unclear how it ranks, which one will start first and which one will give you news later. And this lack of user interface makes it challenging for the users to really realize, okay, I'm getting now news from this, from New York Times, daily news or whatever. So yeah, there are something mechanisms that are missing, and that it doesn't kind of like it makes it difficult in that sense in terms of usability and security and privacy to map it to what was happening earlier with Facebook, that you can precisely know which app is talking to you. Any more questions or thoughts? Okay, so basically this is kind of like the overview of the ecosystem. So we saw it a couple of years ago when we started working on this area, and when we did, basically we started. Gide was basically a PhD leading this project, and we started making like a huge survey, sort of like a state of the art, trying to identify what are the issues within these ecosystems, and some of them we were just discussing with Nissan. But for the purpose of this talk and for a big part of the project, we realized that in general there was a gap in the literature exploring the role of these third-party applications when it comes to understanding security and privacy issues. And there was, although there was a couple of papers that they were attacking certain points of the architecture. So these points. This column on the rightmost side of the slide shows different points of the diagram that I was just presenting. But anyway, while there were like some other recent work analyzing certain points of this architecture, there was basically a gap trying to understand what is the kind of like how these third-party skills are characterized and how they are accessing your private information, and what are the kind of like the collection practices. So kind of like the first contribution in this direction, which was this skill-bed paper that I mentioned earlier. We basically analyze the entire. We develop a crawler to profile to kind of like go through all Amazon Alexa. And we saw that there were kind of like 11 marketplaces. Some of the categories within the different marketplaces would be skills related to games, news, food, drinks, and so on. And the different marketplaces are the usual marketplaces that Amazon has in every country, basically. So yeah, we collected in 2019 about 80,000 skills, and later throughout the years, we kept collecting skills, and we kind of like were trying to understand a little bit better how the ecosystem had been evolving. And but yeah, before we started, we characterized the platform, and we realized that in order to access the personal information, these skills needed to request permissions, and generally these permissions were offered to the user. They appear in the marketplace itself. And at the beginning of this ecosystem, it was not very clear how you could enable some of these skills through the voice commands. But at the end, some of these platforms and Alexa transitioned to a model in which the user had to enable explicitly skills that were requesting permissions through the mobile application or through the web application. And basically at the time, there are kind of like 12 permissions that the skills can request. Some of them are, for example, the device address or the email address. You can access to the location of the users, information about the payments, for example. There is another permission called skill personalization. And yeah, so one of the first steps we did was to collect all these skills, to analyze the different types of permissions that they were requesting. and kind of like understand a little bit better what could be the possible threats to the users. And when we look at the number of permissions that the different skills were requesting, we realized that most of the skills were not requesting permissions. This accounted for 98% of the skills in 2019, and it went all the way down to 97% in 2021. But there was still a small set, but yet an interesting set of applications that they were requesting one permission. And in particular, in 2021, there were 2,000 skills that they were requesting one permission. And then you go all the way to I mean, you can combine all this, and we saw that there are like orders of hundreds that are requesting 3, 4, or even more than 4 permissions at the same time. So at the end, we realized that there were that we wanted to analyze like several thousands. So across the different years, was about 4,000 skills, and obviously going one by one through these different skills was a bit cumbersome to understand. To understand what would be the possible data collection practices these skills were performing. And in particular, we were really interested in understanding if the permissions that these skills were requesting was somehow related to the data collection practices that they were declaring the privacy policy of each of these skills. So to automate this process, we developed this methodology that we call a skill bed, that basically was using machine learning to identify different data collection statements for each of the privacy policies. And the challenge here is that when we started this project, we thought that we could go about using existing methods that people had developed for smartphones. There had been a couple of papers working on understanding privacy policies in the web and some others in smartphones. But we realized that the permission models were different in Alexa, and that the existing frameworks did not really perform well. So we went about training our own machine learning algorithm, which basically there is no magic behind that. We label quite a lot of data collection statements to the permissions that that Alexa had declared, and we train a machine learning algorithm, and we went about automatically analyzing all these privacy policies by doing something that is called traceability analysis. That is kind of like an analysis that basically tells you for every single permission that the application is requesting, whether there is a perfect map between the permission that the app is collecting to a data to a statement in the privacy policy that justifies the collection of that of the personal information that is protected by this permission. And if there is a perfect mapping between all these permissions and these statements in the privacy policy, we say that the privacy is complete, that the traceability is complete. If there is a permission that has not been explained in the privacy policy, we say that the traceability is partial. And then if none of the permissions are declared, we say that the traceability is broken. So we went back to our data collection, to our crawlers, and we apply this methodology to understand how many of the skills that were requesting permission had issues in terms of privacy policies. And here in the top one category, we see the sports category, which basically had 91% of the skills that show a broken traceability. But also on the very top of this chart, you can see categories like kids category, which at the time was quite surprising to find skills that had issues in terms of privacy in the privacy policies in this category, because there is a specific regulation that actually protects kids, and that they really they have to make an extra effort to be careful with the data collections with the personal information they collect from the users. So this is kind of like what we did in 2019, and the interesting bit that we did in our latest that paper was that we went about doing a longitudinal measurement and try to identify how the ecosystem had evolved over the last few years. And in particular, as part of this paper, what happened is that in 2021, we did a responsible disclosure. For every single skill that we saw that it had broken or partial traceability, we contacted both the developers by looking at the email address in the privacy policy and Amazon Alexa. And we reported about 600 skills. Yeah, we explained them basically what was the issues and kind of like we went through a great deal, at trying to make sure that the ecosystem was protected and was kind of like and trying to kind of like make an impact on our paper. And the surprising thing here is that when we were looking, when we did sort of like when we revisited all these 600 skills in 2022, we realized that that out of the 200 skills that they had broken traceability and for which we had notified Amazon and the developers, still 100 and something still had the broken traceability, which means that even though they were aware of the issues, they didn't care to update them. And kind of like this is one of the highlights of the papers. There are many more, but in the interest of time, I just thought I would bring this main one. Any questions or kind of like comments? So the second case study that I wanted to bring today with us, it uses, as you will see, part of the methodology that we developed for SkillBet, and it applies this to another ecosystem, which is the chatbot ecosystem. We presented this this paper in IMC this year, and basically we kind of like wanted to understand if some of the threats that we had identified in the smart personal ecosystem appeared as well in some of these instant messaging platforms. Yeah, but I guess one of well, there are several main differences with respect to what we did with smart personal assistants, and is that we kind of like expanded our methodology not only to be able to identify these issues, kind of like mismatch between the permissions and the privacy policies, but also we kind of like attempted to do some sort of dynamic analysis with yeah, I'm quoting dynamic analysis because this chatbot's also run in the cloud, and it's a bit challenging and a bit difficult to kind of like perform dynamic analysis. So I will explain a little bit later what we did. But yeah, basically the analysis pipeline that we developed for both Slack and Discord has some 4 main building blocks that I'm going to explain in the next 4 slides. The first of it is the data collection methodology, which had some dedicated crawlers, and yeah, there were some challenges crawling these marketplaces that I will guys invite you to read the paper. But basically, after solving these challenges, we were able to collect sort of like the permissions that these chatbots request to access to the personal information, also the privacy policies that are declared in this ecosystem. There is here a caveat which in the Slackbot ecosystem, in this chatbot ecosystem, the privacy policies are hosted in the website of the developer rather than being in a single marketplace. So many of the chatbots don't even have a privacy policy. And similarly, what you can find oftentimes in this in the website of the developer, many of these developers pointed to a link to GitHub hosting the source code of the of this chatbot. So when we found that in the through our crawl, we were collecting that information and use it for further analysis. And then we obviously collected the URL that is required for you later to install these chatbots in a Discord or Slack. So we collected all that information. We went about doing some metadata analysis, which was basically the same methodology that I just described for skill bets and that. Then we attempted to do some partial static analysis on the source code of those chatbots that we identified. And the methodology that we use for this had two main components. First of all, we went for a kind of like for a manual modeling of the permission checks that these platforms do in order to understand if a user has the permissions to access to a certain API or not. And then we went about doing an automatic verification at a scale to understand if the permissions checks were applied to the chatbots that we for which we found some source code. And the final step of our methodology, we did some dynamic analysis. And yeah, as I said, in the kind of like in the absence of the access to the chatbot itself, we had to kind of like think out of the box. And for this, we use kind of like the idea of a honeypot. Basically, we instrumented something that is called canary tokens or honey tokens, which are basically tokens like could be a URL or a Word document for which they have the property that when you interact with those tokens, you can send a signal to the basically to us, okay? And yeah, so basically we use our method which assumes that the chatbot should not be interacting with these honey tokens in a channel unless there is a particular functionality that would justify this interaction. And this method basically allows us to identify any potential leakage or sensitive information. And the way we went about doing this is we designed a framework that control kind of like a control experiment that that allows to test different chatbots. So let's say, for example, we take a workspace in Slack, like the SIGCOMM workspace, or in Discord we did the same. It's called instead of workspace called a guild. And what we did basically is we took every single chatbot that had been installed in this ecosystem, and we install it in our own workspace, in our Slack channel or Discord guild. And obviously, to make a or kind of like our honeypot look real, we kind of like fed it with real messages that we took from Twitter, but sort of like we populated an Slack channel in an automated way, and we install only a chatbot per channel, and then we kind of like posted different honey tokens into this channel, files in Office and PDF links and email addresses. And when if this chatbot is accessing to any of those tokens, we basically get a signal that allows us to understand if there has been a leak of a misuse by this chatbot. So this is kind of like an overview of the entire methodology. And now what I wanted to kind of like show you is, again, in the next 4 slides, a summary of the results we got. For the data collection process, we scrape very popular markets, but yeah, long story short, we collected 21,000 chatbots, out of which 75% requested permissions. The top 2 permissions that we saw that they were requesting was sending messages on behalf of the user and being able to perform administrative tasks on the workspace. And basically, this admin permission is kind of like a proxy that grants the chatbot developer access to any other resource basically gives you all other permissions that you can see here, all those other permissions that you can see here in the slide. So kind of like the first takeaway we saw is that in general the chatbot ecosystem is overprivileged. It's surprising to find that almost half of over half of the chatbots, they can perform, they can have all these many privileges and permissions. Then the next step of our methodology was the metadata analysis. So basically, we saw that out of all the chatbots that we saw, only a handful of them had privacy policy. And when we deep inspected these 600 policies, we realized that none of them had a complete traceability, and most of the privacy policies were not tailored to the ecosystem, which brought us to the second takeaway, that basically we realized that chatbots don't explain data collection practices to the users. The third step of our methodology was this partial static analysis. You may recall had two main phases, the modeling phase and the automated verification phase. So from the first phase, we discovered that there is no runtime checker in Discord. Basically, this means that the Discord platform does not, when you install a chatbot in a Discord guild, and that chatbot had a number of permissions, like the administrative permission. If a user that may not have the administrative permission install these chatbots, through the use of this chatbot, they can end up using, they can basically escalate privileges, basically because the platform is not checking whether the user has the same permissions as the administrative, as the chatbot. And this is called permission redelegation attacks, or kind of like, so kind of like this is the one of the main takeaways of our paper. Then we went about, after we realized about this, we went about profiling the API calls that the developers, because one of the implications of this is that then the Discord redelegates on the developers the important task of checking whether a user is supposed to have the permission to access to a resource or not. So is the responsibility of the developers to do this kind of checks. So we model what are the checks that a developer is supposed to be doing in order to realize if a user has the right permissions or not. And basically, we found a number of API calls that are supposed to be invoked by the developers. And then we went about doing an automated analysis over the 2,000 chatbots for which we had the source code. And we realized that for those that were written in JavaScript, only 27% out of 900 were performing the right checks that was giving the developers the guarantees that the user has the permissions to perform an action. And in Python, this went all the way up to 97% of them. So the other takeaway of our paper is that the users can take advantage of this of the privilege of a chatbot to perform a redelegation attack. And yeah, just to kind of like wrap up, the last very step of our methodology was the dynamic analysis. And yeah, we for this step of our methodology, we tested a diverse set of chatbots. We started looking at the most voted chatbots, but also the ones that had been installed in more than 250,000 workspaces or guilds, meaning that a lot of users had installed these chatbots. What I'm going to show you next is the case study of a chatbot that is called Melodian. Melodian chatbot is basically a chatbot that declares itself as being a chatbot that helps you to do some moderation in your channel, that allows you to do some fun stuff, something that gives instruments to the users of that workspace, basically. but when you look at the description of the Melodian chatbot and you inspect the privacy policies, you immediately see that there is no legitimate purpose for the set of actions that this chatbot is supposed to be delivering for opening Word documents or visiting URLs that people post on their own channels. And basically what happened with this case study is that, we went about the instrumenting our Discord ecosystem. We populated with a lot of messages, and then we posted a Word document that had a honey token. And we realized that that this honey token had been triggered, and that there had been, so that the chatbot, the developer of this chatbot had been accessing to several of the documents that we had posted in our workspace. And something that we miss because when you do these kind of experiments, you try to think about all the corner cases, but obviously you always miss something. And although our platform, the workspace looked very real in terms of the number of users and the messages that people were, the users that they were posting in the channel, when we posted these honey tokens, these Word documents, they didn't look real. Basically, the Word documents were just empty documents, and they were like, I don't know, 5 or 6 of them or something like that. So when the chatbot developer realized about the that this could be a honeypot, he posted, or she posted a message in the Slack channel, a very polite message, wondering what was this what was our workspace about, basically. But anyway, apart from this anecdote, you can clearly see that Melodian basically had been violating Discord's privacy policies, that it had been infringing computer fraud and misuse acts, and that it confirms the lack of control and awareness both from the Discord platform, but also the users itself. And the finding for this last step of our methodology is that we found the first instance of a remote access Trojan, a malware, which basically is this Melodian case that has been used as a proxy to exfiltrate information from thousands and thousands of Discord channels around the world. And this was a summary of the main takeaways of this talk. And in the interest of time, I'll just open the floor for questions. Also by leaving this shameless plug here, that if you guys like the research we do, I'm hiring here at IMDEA. We have a lot of fun, not only in the lab doing these kind of things, but also out of the lab. As you can see in this small video, we went surfing a couple of months ago here in Madrid. So if you like to do a PhD or a postdoc, just feel free to drop me a line. Thank you, guys.
Can I do a PhD with you? It looks fun.
Want to do a PhD too, I'm sure.
You know that the test, the exam, the interview requires you to do some surfing.
Okay, I was afraid you'd actually make me do some coding, which I would not pass now.
Well, I will get my speedos ready.
Yeah. Cool. Any questions, anyone?
Yeah, very cool stuff. So what can be done?
Sorry, say it again.
Helps to prevent these things from happening.
Oh, okay, yes. So it's tricky, right? Because we had in the case of Amazon Alexa, we really tried to do our best to raise awareness and to report this kind of malicious or kind of potentially unwanted skills, and we didn't get a really good response. In academia, a lot of papers, they are proposing new architectures and new ways in which all this could be solved. And I guess on the long run, big guys like Amazon, they will tap into those papers and improve their architectures and the design. But from the point of view of a guy that likes measurements and that likes looking into this ecosystem, the main thing we can do is to name and shame, to continue naming and shaming to these platforms as much as we can.
So I had one thought, right? So you said a large number of applications are already asking for admin permissions already. And I wonder if you continuously downgrade from admin down to, I don't know if there's a proper hierarchy of all the permissions you said or not, or maybe even just random subsets of those permissions. Maybe they're just asking for admin permission because it's the easy thing to do, right? And there are probably some amateur coding people who just came up with some chatbot for their specific need and they've released it somewhere on some GitHub. And so it's just a matter of using the right permission and seeing which one still does the chatbot continuously keep working despite this lowering the permission. Is that something that could be done? Like, the manifest says admin permission is needed, but you give it a lower permission and see how it works.
Yeah, I think that is something you could do. If you are the administrator of a Discord channel, you could. I think you could downgrade the permissions of because a chatbot effectively is almost like a user, and you could kind of like override in some cases some of the permissions that they are asking.
Yeah, and then seeing actually, what they're asking for admin permission, but all they need is read permissions, and everything else will continue to work.
Yeah, I think that could be a good way to. But one of the issues with these platforms is that they are kind of like distributed, or not sort of distributed, but kind of or federated in the sense that there is no single central Discord server that you could apply a mitigation like that, and then all of a sudden have an impact into millions of users. But every Discord guild is being run by a different administrator, and that makes it a little bit more challenging to kind of like scale some measures like that.
Any other questions from anyone?
Walid, don't be shy.
I have one other question if I'm not getting in anyone else's way. So there's this whole thing about Slack versus Discord versus Matrix. Actually, nowadays with Matrix is being thrown around as an alternative for Mastodon as well. Do you see any like fundamental differences in their approach between, let's say, Slack and Discord, or Slack, Discord, and Matrix?
There are substantial differences, starting by the fact that Slack, I would say that is a little bit similar to iOS, that they try to, the marketplace for the chatbots is, they try to bet it. So there is more control, there is like a big business behind it, that they are able to make more money than Discord in general, and they have more resources and interest to make sure that the Slackbot applications are legit. And and in the case of Discord, it's a bit it's more like Android, in the sense that the marketplace is not a walled garden. By default, the policy is that people can install. There can be as many chatbots as you want. I mean, there is not even like a marketplace like in a Slack that is centralized. You can host your chatbot into your GitHub repository, and people will just with one command will install it, and the Discord itself, the community Discord, may not even know that there is a chatbot doing those kind of things, maybe installing in a given guild.
Interesting. So do you think there's more? I don't even know whether, for example, the stars on us, if you have some chatbot in something like Slack, which has like 4.5 stars, is that somehow more trustworthy than a 3-star one? Or sometimes security has nothing to do with how popular something is?
I would say that there is no correlation. There might be some like a small causation because if you, as a chatbot developer, all of a sudden become so popular that you have 5 stars and a lot of users, you have a little bit more of incentive maybe to behave properly because maybe you have an opportunity to monetize that somehow. But as we have seen as well in other ecosystems, like in the smartphones, the number of stars doesn't really, it's not a good proxy for how secure or how, private a developer is.
Yeah.
Do you think this is driven by malice or by convenience?
In the case of the Melodian one, it's malice. I mean, it was clearly the intent to kind of like make cursor inspections of the content that people had been posting and probably monetizing that some in underground forums or whatever. In some other cases, I think developers, we know that they are oftentimes very sloppy and careless, and clearly they might have like they might not even have the intention to do something bad. They just didn't learn from that they had to perform the permission checks themselves, and they don't have that.
That conveniently brings us to the top of the hour. So unless there are any burning last-minute questions for Guillermo, we thank him in the traditional way, and we wait for the next month's entertainer for NGN, who would be, I think it's Paul Patras next month, if I'm not wrong.
Thank you all,
Guillermo.
and looking forward to see you face to face.
Yeah, let me know when you get here.
Yeah, I'll drop you guys a line.
That's good. Bye.
Thank you very much.
Bye.
Take care. Bye.
Bye.